All right, welcome back to College Algebra. So we are going to talk about chapter 2.4 right now and get into that. Now, the first thing I want to tell you is that chapter 2.4 is a bit of an abbreviated chapter for us, okay? I will also warn you that chapter 2.4 is going to be difficult no matter how abbreviated it is. So even though it's shorter, doesn't matter. It's still going to be kind of rough, okay? So here's the idea, okay? Let's see here. Let's start off with something that seems like it has a name that would look like it's really important, and it is. Okay, Fundamental Theorem of Algebra. And what this says is if f of x, right, is a polynomial, all right, of degree n, which is at least one. Okay, so a line, a parabola, a cubic, right, at least one, with complex coefficients. That means we're allowed to do something like y equals 1 plus 2ix minus 3. Okay, and that's okay. So in this case, we're allowed to do this. So with complex coefficients, we're also allowed to do this. Right, 2 is technically a complex number because it's 2 plus 0i. All right, so even though it might not look like it's a complex root or a complex number, technically all real numbers are subsets of complex numbers. So, you know, that this is fine. Okay, this is also included. With at least, then f of x has at least one complex zero. All right, and that was, you know, that was a bit. That was a proof that was a bit. So, you know, my question was, great, where is it? I'm like, no. That's a completely different theorem. And for some of those, you get to learn about those in trig. So this is just saying that if they have complex coefficients, that at least 1 0 exists. Okay, thanks. That's helpful. We can go on to say, okay, this is another theorem, okay, that the number of zeros a polynomial has, okay, the number of zeros a polynomial has. Let's see. If f of x is a polynomial with degree n, okay, and it has complex coefficients. Okay, so, you know, like I said, 3 is a complex coefficient. So all it does is say, well, we can use real numbers or complex numbers, and this will all work out. Okay, so we have complex coefficients. Then f of x, okay, with n degree. Then f of x, okay, has exactly n zeros if we count each of the multiplicities, okay, provided that each zero, okay, is counted by its multiplicity. What's that mean? Well, it means that if you have an x to the third, right, I'll say a x to the third plus some stuff, so maybe there's an x squared, maybe there's an x, maybe there's a constant, then we have 3 zeros. We might count some of them more than once, but we will have 3 zeros. Okay. X to the 4th has 4 zeros. X to the 4th plus 1 has 4 zeros. All right. So when they're going to ask you to find the zeros, and they say, okay, we have an x to the 5th, and they're going to give you a hint. They're going to tell you, like, hey, here's a 0, like -3, and 1 plus I is a 0. Well, when we do our synthetic division, right, we're gonna figure out, we put the -3 in, right, we're gonna have an x to the 4th, and then we're gonna put 1 plus I in, we're gonna have an x to the 3rd, and then automatically, right, this is the conjugate zeros theorem. So if a complex number is a 0, then so is its conjugate. Okay, so if we have values with real coefficients, if you have a 0 that's a complex number, then its conjugate automatically is. So if I just tell you these two, right, we have, well, that'll, that's 1 0, that's another 0, that's another 0. Well, so far now we have 3 zeros. 5 minus 3, right, we're going to do 3 division problems, and that'll knock this thing down on x squared, right, which is a quadratic. And to find the other 2 zeros, you have to figure out some kind of a formula to be able to solve a quadratic. So we'll get to that when we'll cross that bridge when we get there. Okay, so that's what you're using this theorem for, is that, you have an x to the 5th, you should expect 5 zeros. We're also going to use the conjugate theorem. So if they only give you 1, you automatically, know that the other one is automatically there. Right? So if I have an x to the 6th, we have 1 and like I. Okay, and let's see. We'll do 1 plus 3i. Then I automatically know that negative I, because that's the conjugate of I, and 1 minus 3i are also zeros. So now we've accounted for 1, 2, 3, 4, 5 zeros, which should be very easy to get the last one. Okay, it should just be a linear equation to solve. All right. So that's all that's saying. Okay, we know how many to look for, and we know some of them come twice. Okay, so so there. We're also going to be building polynomials with specific conditions. Okay. So they might tell us, hey, the 0, right? They might say f of 0, the y-intercept is a certain value. So really what we're going to do, they might say like 109 or something. Okay. So really what we're going to do is we might have a whole bunch of linear factors, x minus a, x minus b, dot, 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 right? And when I plug in 0, then we're going to multiply up all this stuff. And so, but wait, it doesn't equal that. Like, I know. But, we can put a number out in front and then multiply all this stuff and then divide by, all of the stuff that, that's left, and then divide by that and get k equals that, so that we know, right, what we're going to multiply it by in order to get the answer they want. Okay, that's really all there is to that. And always, right, as always with stuff like this, like is easier said than done for a lot of these. Okay, so let's see. I wanted to do 1 or 2 examples for us just before we get into the homework, but rest assured, I will definitely do a homework walkthrough for this, because none of these problems are really going to be all that much fun. But let's see. I could do 39. That's a pretty straightforward one. 40. We'll do 40. Okay. So as we have a degree 3 polynomial with integer coefficients and zeros of -4i and 3 halves. Okay. So we know that we have a degree 3. We have -4i and 3 halves are zeros. Well, what do we know about -4i? That it's a 0. So we know automatically, right? Plus positive 4i, that's its conjugate, right? It's 0 minus 4i, we have 0 plus 4i. That middle sign changes. And then here we have x right? X equals 3/2, we know that that's a 0. Well, do you remember the process we got to make zeros, right? We'd use the zero factor principle, we'd set these off, we'd set all of these things out, and we'd set each term equal to 0. Okay. So why don't I take this and I multiply both sides by 2? So we have 2x is equal to 3. And I will subtract 3 from both sides. So we have 2x minus 3 equals 0. This was a factor, okay? And since they told me they have to have integer coefficients, I would rather put it in like this than to put it in. I mean, this is not incorrect, okay? But we're not going to end up with integer coefficients anymore. So that's why I went through and done all of this, is because the 2x minus 3 is a factor, it still gives us the same 0. Okay, so in this case, we know that, right, x equals negative 4i. So we could say x plus 4i equals 0. But we also know that x is equal to 4i. So here we're going to get x minus 4i. We want back to real number coefficients, right, with this one. So what we're going to do is we're going to take x plus 4i and x minus 4i, and we're going to FOIL this out and see what happens. Okay, so we get x squared, we get plus, right, plus 4ix, right, and then we get minus 4ix. That's why we chose conjugates, so that these terms go away. And then we have minus 16i squared. But you know what happens with I squareds, right? I squared is really negative 1. So negative times negative is positive. And these two terms cancel it out. Okay. So the polynomial I would build, right, would look like x squared plus 16, 2x minus 3. Right. I suspect your book makes you, right, or multiply all of this out, which is kind of good because, you know, we all need the practice. But at the same time, I do understand that it gets a little tedious. So for my example here, I'm going to go ahead and stop it right there. And we can, as we're doing the homework, we can go through and deal with multiplying everything out. Okay, so I'm going to go ahead and stop this video here, and I will be back with doing some demonstrations and some homework walkthroughs. And you know, these, I know these are going to be a little rough. Okay, they take a long time, but that's okay. I know you guys can get through it, and you know, they're not, some of the problems aren't quite as bad as others. Okay, so I'll be back in a little bit, and I will see you then. All right. Stop recording.